Let's take a look at some properties. Welcome to the identity and equality property. Properties in algebra are very important. These properties have been proven by mathematicians over and over again, and they found that they will work every single time, so they decided to give them a name. Just like in math, you have fact, which is proven, or you have a theory. Well, the properties in math are fact. They will happen every single time. And they've given them pretty reasonable names. Additive identity is an example of when you add something and you get this exact same thing back. Think of identity as a mirror. And think to yourself, if I add something to a number, what do I add to get it back? Nothing. So if I add 1 plus 0, I'm going to get 1 back. Just like when you look in the mirror, you see yourself. And the same with multiplicative identity. If I add, well, that's addition. Multiplicative, long word, that means multiply. What can I add to a number to get that same number back? And in multiplication, anytime you add 1, or I'm sorry, not add, anytime you multiply 1 to a number, you get that same number back. Well, in the multiplicative property of 0, what that's saying is, sorry about that, any number multiplied by 0, notice we have 0, and multiply will always give us 0. If I have 200 times 0, it will always give me 0, hence multiplicative property of 0. The multiplicative inverse is just another name for reciprocal. And what that means is any number, if I have 1/8 and I multiply it by the denominator, and what I did was, really, I flipped it. I have 1 over a times a over 1. It will always give me 1. The reason being is because if I have 1 over 5 and I multiply it by 5, remember a whole number I can turn into a fraction at any time by putting 1 under it. And you multiply your numerators. 1 times 5 is 5. 5 times 1 is 5. And 5 divided by 5, because a fraction is just a division, will always give you 1. When using these properties, not only will they tell you what to do next in a problem, but they'll tell you why it works in a problem. Use these properties to manipulate the problems or to solve the problems. Let's take a look here. Name the property. 42 times n equals 42. Well, I have multiplication, so I know it's multiplicative. And I have 42 times something will give me 42 back. So I'm technically getting the same number back, or I'm getting the identity. And that would be the multiplicative identity. Here I have a number times 9 equals 1. Which one of these properties will give you 1? what number do I multiply times 9 to get 1? I have multiply, so it's multiplicative. And the only thing I can multiply times 9 to get 1 is its inverse. So if I say 1 times 9, the inverse of 9 is 1/9, I will always get 1, just like we did with the 5 up there. Now let's see here. 28 times n equals 0. Remember, if I don't see an operation, it's multiplication. So it's multiplicative. And I'd multiply any number times 0, where n would be 0, in order to get 0 as my product. So that would be the multiplicative property of 0. Let's go ahead and take a look at another one. Okay, let's take a look at these properties: the reflexive, symmetric, transitive, and substitution property. The reflexive property tells me that any quality is equal to itself. Once again, it's reflection in the mirror. I think they like mirrors here, dealing with identity and reflexive. So I can say A equals A. If A is 5, that means 5 is going to equal 5. I can also say any expression, 7 plus 2, is reflexive of 9 because they have the same value. Your reflexive property will have the same value on both sides. In your symmetric property, you're kind of switching things around. What that says is if A equals B, then B equals A. Now let's use this example up here. If 7 plus 2 equals 9, then I can say 9 equals 7 plus 2. In other words, anything that is symmetric is the exact same thing right down the center, or right down the equal sign. Now, I'm going to jump ahead to substitution. Substitution is exactly what it says. I'm substituting a quantity that is equal. So, if n equals 15, then I can say 3n equals 3 times 15. Notice I substituted the 15 in for n, or I replaced it. That's called the substitution property. Yeah, believe it or not, they actually have a property for every time you plug in a number. I know it's silly, but they do. Okay, now back up to my favorite property, the transitive property. It's kind of a long property. It's a property a lot of people tend to forget, but it is my favorite property. And what that's saying, you can apply the transitive property to so many things in life. If you have A equals B, and you have B equals C, then you can say your A therefore equals C. See, if A equals B and B equals C, then your A will equal your outcome, or your beginning will equal your outcome. Let's look at numbers this way. In transitive, if I say, let's try another example. If 5 plus 7 equals 8 plus 4, and 8 plus 4 equals 12, then 5 plus 7 will equal 12. In other words, they all have the same value. Notice they all have the same value. Okay, so if the first one equals the second one, and the second one equals the third one, then the first will equal the third. I love those properties. And it's always true. They haven't proven it wrong yet. Okay. This is the tough one. I think this is probably the toughest section that my students have problems with. It's not necessarily evaluating using PEMDAS, but what did I do to evaluate? Which property did I use to evaluate? Now, according to PEMDAS, what would you do first? You would say, look inside your parentheses. Remember, PEMDAS is please excuse my dear Aunt Sally. So I'd look at parentheses first. And inside those parentheses, I would ask, are there any other parentheses? Nope. Are there any exponents? Nope. Is there any multiplication and division? And there is, right here. So I'm going to rewrite my problem, saying 3 times 2 is 6, minus 5, plus 3 times 1/3. What did I do? I solved. 3 times 2 equals 6. Good. But which property did I use? I used substitution. Because I substituted 3 times 2 for 6. I'm sorry, I substituted the 6 in for 3 times 2. Okay, so let's take a look at another one. According to the properties, what do? I solve inside my parentheses, which is 6 minus 5, and 6 minus 5 equals 1, plus 3 times 1/3. What did I do? I solved, instead of writing the 6 minus 5, I wrote the 1. So I used substitution again. And I said 6 minus 5 equals 1. I substituted. Okay. Now, according to operations, I'm going to multiply. And I'm going to multiply 2 times 1, because that comes first. 2 times 1 is 2. Well, I can say, I said 2 times 1 is 2. Yeah, technically you substituted the 2 for the 2 times 1. And that's what a lot of my students want to say. But if you go back, what property is that? A number times 1 will give itself back. Multiplication, which is multiplicative, and I get myself back, or I get the same number back, so that's identity. So it's a multiplicative identity. Rewriting my same. Now, in this case, I have multiplication. I have addition and multiplication. According to PEMDAS, I solve multiplication first. And when I solve 3 times 1/3, what am I going to get? 3 times 1/3 will give me 1. Notice if I put a 1 underneath it, because I can put a 1 underneath any whole number and keep its value, or any number I can put a 1 underneath it and keep its value. These are reciprocals or multiplicative, again, because it's multiplying. And these are inverses. So I use the multiplicative inverse property. So I have 2 plus 1, and when I solve 2 plus 1, I get 3. I used substitution. And I like to tell myself, well, did I get the 2 back? Did I get 0? Did I use the inverse? Pretty much when you go through those, if you don't, then it's substitution. Let's go on and try another one. Okay, here I go. I'm going to use order of operations to solve it. Please excuse my dear Aunt Sally. I need to solve inside the parentheses first, so I take a look at inside the parentheses, and I have no more parentheses inside the parentheses. I have no exponents. I do have multiplication right here, and that's what I'm going to solve. And I'm going to ask myself, what is 15 times 1 over 15? If I put a 1 underneath it, so they're both looking like fractions, or appear to be fractions, but I keep the same value, I get 1. This is called I multiplied, so it's multiplicative. And these two are the inverse, or the reciprocal of each other, so it's multiplicative inverse. So 1 plus 8 times 0 times 12. Okay. Now I have addition and multiplication. According to PEMDAS, I solve my multiplication. I'm rewriting my problem. And 8 times 0 is 0. What property tells me that any number times 0 is 0? It only happens, 8 times 0 is 0. What happens when you multiply? So we use a long word for multiplication or multiplicative. And I get 0 for an answer, so it's a multiplicative property of 0. Okay, here I have 1 plus 0. Still work inside my parentheses. And 1 plus 0 is 1. And any time you multiply, you add a number to 0. Did we go over a property that you add to 0 and get itself back? No, we did not. Yes, we did. What property is that? I'm adding. I added 1 plus 0, and I got 1. I didn't get 0. I don't know why I was saying that. You add, so it's additive. And when you get the original answer back, that's called the additive identity. and I need to know how to spell. Please make sure you spell these right. You're going to drive your teacher crazy. Okay. Now, once again, a lot of people want to put substitution, but please take a look at it. I added. I got the very first number back when I added it to 0, so therefore it's called the additive identity. I got itself back. Okay, now 1 times 12. 1 times 12 is 12, and that's my answer. But 1 times 12 equals 12. I multiplied, so it's multiplicative. And I got itself back, so that's your multiplicative identity property. Very good, you guys. Very good. Let's do another one. Whew, this is a long one. Okay, start with order of operations. This is why I put this in here. Please excuse my dear Aunt Sally. Inside parentheses, always start with parentheses and working left to right. So I have 1/4 times 12 minus 8 is 4 plus 3. I'm going to rewrite the problem here. Okay, and I solved 12 minus 8, and I got 4. That would be substitution. I still have parentheses, so I'm going to solve inside the parentheses, rewriting my problem. Now, what do I solve first? I have division and subtraction. According to PEMDAS, I do the division first. And 15 divided by 5 is 3. And that would be substitution. Okay, now I still have to solve inside the parentheses. I'm going to rewrite my problem. And 3 minus 2 is 1. I write down what I solved. I know that it looks like it's times. Once again, substitution. Okay, now I have to do multiplication, left to right. 1/4 times 4, those are inverses. 1/4 times 4 always gives me 1, because I put a 1 underneath it, and 1 times 4 is 4. 4 times 1 is 4. Excuse me. That is multiplicative, because I'm multiplying, and it's the inverse because I flipped it upside down. And 1/4 times 4 is 1, plus 3 times 1. When I multiply 3 times 1, I get 3 back. I multiplied, multiplicative. I get the identity back, or itself back, so it's multiplicative identity. And 1 plus 3 times 1 is 3. And 1 plus 3 is 4, which 1 plus 3 is using substitution. Because I substituted, instead of writing 1 plus 3, I substituted the 4. And that is it on identity, and equality properties. If you have more questions, go ahead and email me.